Fifth generation wireless, 5G is the latest iteration of cellular technology, engineered to greatly increase the speed and responsiveness of wireless networks. With 5G, data transmitted over wireless broadband connections can travel at multi-gigabit speeds, with potential peak speeds as high as 20 gigabits per second by some estimates. These speeds exceed wireline network speeds and offer latency of below 5 milliseconds or lower, which is useful for applications that require real-time feedback. 5G will enable a sharp increase in the amount of data transmitted over wireless systems due to more available bandwidth and advanced antenna technology. 5G networks and services will be deployed in stages over the next several years to accommodate the increasing reliance on mobile and internet-enabled devices. Overall, 5G is expected to generate a variety of new applications, uses and business cases as the technology is rolled out. Wireless networks are composed of cell sites divided into sectors that send data through radio waves. Fourth generation, 4G long-term evolution, LTE wireless technology provides the foundation for 5G. Unlike 4G, which requires large, high-power cell towers to radiate signals over longer distances, 5G wireless signals are transmitted through large numbers of small cell stations located in places like light poles or building roofs. The use of multiple small cells is necessary because the millimeter wave spectrum, the band of spectrum between 30 and 300 GHz that 5G relies on to generate high speeds, can only travel over short distances and is subject to interference from weather and physical obstacles, like buildings or trees. Previous generations of wireless technology have used lower frequency bands of spectrum. To offset the challenges relating to distance and interference with wave, the wireless industry is also considering the use of a lower frequency spectrum for 5G networks so network operators could use spectrum they already own to build out their new networks. Lower frequency spectrum reaches greater distances but has lower speed and capacity than wave. 5G download speeds can currently reach upwards of 1000 megabits or even up to 2.15 gigabytes per second. To visualize this, a user could start a YouTube video in full HD quality on a 5G device without it buffering. Downloading an app or an episode of a Netflix show, which may currently take up to a few minutes, can be completed in just a few seconds. Wirelessly streaming video in 4K also becomes much more viable. If on wave, these examples would currently need to be within an unobstructed city block away from a 5G node. If not, the download speed would drop back down to 4G. Even though the downsides of 5G are clear when considering how easily wave can be blocked, or less clear considering radio frequency exposure limits, 5G still has plenty of worthy benefits, such as use of higher frequencies, high bandwidth and enhanced mobile broadband. Thanks for watching TechUx, all about tech.